All right. Hello, everyone. So last time we talked about Spark data frame basics. So today we're going to continue talking about how to handle um, data sets using PySpark. So before to get started, since we stopped last time in the middle of processing things, I believe quite a bit of code that we have written last time. So um, for your convenience, I have prepared this September 17 class base code under the labs section in module 2. So if you click that, then there are codes that you can copy and paste. Okay. So I'm going to give you some time to, unless you have the notebook from the previous class, I'm going to give you some time to copy and paste the code over here. Okay. We're not gonna need everything from the last class, but the code that is necessary for reading the CSV files. So this is what we need for today's class. Okay. So if you copied and pasted, then go ahead and run the cells. And by running the cell, it'll configure PySpark. It'll download the CSV files from the baseball data bank dataset. And then finally, by running this cell, we'll have the CSV files loaded up as a data frame in PySpark. Now, last time we talked about some of the basic operations of querying the information, selecting selecting columns and selecting rows. Now, one thing that's left, and which can be quite useful, is to merge different tables and then produce a new information. Okay. So to do that, what we're going to learn today is this function called join. So join function is literally to join two tables. So the use of it is simply you can go by df people.join and df bedding. Okay. And this is basic usage of how you could join the table. Of course, there's more into it. So, but essentially, what it returns is a new data frame that has combined the two tables. Now, unfortunately, if you run this one works just fine. But then when you try to show the contents of the combined data frame, you will notice that there's an error. Okay. This is, again, relevant to what I explained last time. Last time I explained that everything in PySpark lives as sort of an optimized query. So the column object, for example, was just a query, right? A column object or row object was simply just a query object, which contains a short code of what kind of information you will need to retrieve from the actual data set. So until the moment that you call something.show, everything exists in the form of query sequence. And only when you run something.show, it starts to retrieve the actual values. Okay. So that is actually the reason why we did not have a problem running this cell that I highlighted over here. But when I try to run this cell, we start to see an error. Okay. So we created a query a code that says how this new data frame can be created, the new data frame called the df combined. We just created a query of how to create this new data frame, but we never actually executed any computation. Okay. And since everything exists in the format of query, this looks just fine. But then the moment you try to show, the moment you try to print the values, it starts to complain about it. Now, the reason for this complaint is because the joining operation is not so trivial. The reason for that is, let's say, let's try to see how each of the data frames look like. So df people dot show, and I'm gonna show only 5 lines, and then df bedding dot show 5 lines. And if you look at it, the table on the top is the people table, and then the table at the bottom is the bedding table. And then it seems like if you look at the column names, okay, there's no sort of overlap between the two. There's no common column name between the two tables except player ID. Okay. So as a human, right, when you look at the table, it becomes obvious that player ID is something that connects these two tables. Okay. So for example, since I printed only 5 lines, I cannot find any corresponding player ID. But what you can do conceptually is in the people table, here's a player ID, AARDSDA01. That's the first player's player ID in the database. And then what I'm going to do is then to look for that player ID in this new table. And then I find that row. Let's say that player exists in the seventh row. Okay, so then what I'm going to do is to copy the contents of that corresponding row and then append that at the end of the people table. So that's basically what I want to achieve here. But it is not so obvious for Spark that which column has to act as a key variable that connects the two tables. So you actually have to explicitly specify what is the key variable that you want to use to connect the two tables. So here, here what I'm going to do is inside of the join function, I'm going to add an optional argument called on. And then in there, I'm going to type player ID. Okay. And I'm going to rerun this cell. And then next, I'm going to run df underscore combined dot show. And now, well, maybe let's display only 5 lines because we don't need everything. Now, as you can see over here, we have the original people table appended by the bedding stats. So in the bedding table, we had year ID, stint, team ID, league ID, games, at bats, run, hits, 2B, 3B, right? So all of these informations are appended at the end of the original people table. Okay. So this is basically how you could combine 2 different tables to create a new data frame. Okay. So it's not so difficult if you understand the syntax. So a possible usage. So let's try to apply what we learned from last time and what we learned just now. For example, let's say you want to build a list of top 10 career home run, right? So here, what we want to compute is we want to rank players by the number of home runs. And the problem here is the batting table does not have the player names. We only have the player ID and the home run column. But other than that, we don't have the actual name of the player. Okay, the actual name of the player can only be found in the people table. So in the people table, we have name first, name last. So those are the two columns where you can retrieve the actual names of the players. So what we want to be able to do is to combine them together to compute, to construct a new table that has perhaps the player ID, number of home runs, and the first name and the last name. Okay, so from the people table, I'm going to select. Okay, remember the select function was a function to select particular columns and then create a new data frame, right? So what we're interested in is the first name and the last name. So name first is the name of the column. So name first, name last. And since we have to merge the two tables together, we will also need the player IDs. So I'm going to select those three columns from df underscore people. Okay. And after selecting them, I'm going to join them together with what? With the betting table. So df underscore betting. And the betting table, we don't need the entire table. In fact, we only need the column that's about the number of home runs, right? So to do that, what I'm going to do is, again, I'm going to select df betting dot select player ID, again, because I need to merge them together. So player ID is the key variable. And then I'm going to select the home run column. And now I'm specifying what exactly is the key variable for the merging. And the result of this is going to be stored as simply df. Okay, so now after running this line, if I call df.show, then you can see I have much more concise table that is easier to understand. Okay, so again, we have a list of players and then the number of home runs. Okay, so some players never had hit home run. Some players have 2, 3, 1 home runs. Now, what we want to be able to do is to basically sort them, right? Based off of the number of home runs. So what I'm going to do here is, before showing the result, I'm going to, before showing the result, I'm going to sort the table with respect to the number of home runs. And I want descending order because I want to see the players with the most home runs, the largest numbers, right? And that's it, right? So if I run this, then there you go. Now you see that the players has been sorted based on the number of home runs. So Barry Bonds had 73 home runs. Mark McGwire, 70. Sammy Sosa, 66. Mark McGwire again, 65. Sammy Sosa, 64, and so on and so forth. So you can see the list of home runs sorted in the order of descending values. Okay. Now, there's one problem. What I intended to do was actually to compute the career home runs. But it seems like everything is computed based on an annual home run, so home run per season, right? So if you think about it, for example, the player named Sammy Sosa had 66 home runs in one season, and then in the other season he had 64 home runs. In the other season he again hit 63 home runs. So that's why we're seeing this name multiple times. Same thing with Mark McGwire. Same thing with Ken Griffey. Is it junior or senior? I don't know. But, as you can see, there are people with, their names mentioned more than one time. Babe Ruth here is also mentioned twice. So we need to somehow group them together by their player ID, perhaps, and then compute the summation of the number of home runs. Okay. So to do that, what I'm going to do is I'm going to create a new code cell. And here I'm going to show you this thing called df dot group by. Okay. So the group by function is literally a function that groups rows according to the key value. So the rows that has repeated appearance are going to be grouped together. And then later on, we will be able to take the summation over those individual groups. So what we're trying to do here is we're going to try to group the new table by player ID so that we can compute the summation for each of the cases, each of the players. So if you run this df.groupBy function, the output of that is this new thing called the grouped data. So grouped data object, again, simply speaking, this is yet another search query. Okay. So the output of this is a computer code that describes how the information needs to be retrieved, not the actual data themselves. Okay. So, and since this is not a data frame, it doesn't make sense to, call .show. So before that, I'm going to show you then how we could take the summation, okay, over the number of home runs. So that's indeed simply, you can just call .sum. And the .sum operator here is going to take the summation over each group, the group defined by the player ID. And now let's see what happens when I call this. So df group by player ID .sum. I'm going to call this df underscore career because we're taking the summation over the entire career. And now I'm trying to show what's stored in it. Okay. So then by printing this df underscore career, you see that the home run records has been summed, right? Based off of player ID. Now, since this is not sorted, let me sort it again. So df underscore career dot sort df sum of HR, because that's the that's the new column name. That's the column name of the table. So df sum parentheses HR, and then descending order dot show. Okay. So if I do this, oops. Sorry, not df underscore career. And after a while, you see that it retrieves the top 20 players in terms of the career home run. So now the numbers are much bigger. So it seems like the first one is Barry Bonds. In total, he has recorded 762 home runs throughout the entire career. It seems like this one is Babe Ruth, 714 career home runs, and so on and so forth. So there are all those legendary players who has scored a large number of home runs throughout their entire career has been listed in this table. Now, one thing you might have noticed is that, so this is the previous table, okay? And this is the annual home run record. And now if you look at this, I called the sum, right, of that original data frame. And for somehow, name first and name last has been lost, okay? And that's because the data frame has the schema. Remember that? We talk about the schemas when we first talking about the data frames. And the data frame has a schema, and then the columns, name first and name last, the data frame knows that those are the string variables. And obviously, string variables are not so trivial to add up. For example, what is the addition of Barry plus Mark, right? So it is impossible to add the string variables. So what this function does is it searches for, it searches through the database schema and then find the numerical values, which is in this case only this column. And then for the numerical variables, it conducts the summation over a group. Okay, and here the group is defined by the player ID. So this row and this row, those two rows belongs to the same group, so their numbers are added together. Okay, so that's what happens. So unfortunately, we wanted to display the first name and the last name right after the number of home runs, but somehow we have lost, right, that first name and the last name. But don't worry, because this is something that we can easily fix. So, for example, I'm going to just name this, and then I don't need to show. I'm going to name this sorted table as df top. And, oops, and what I'm going to do is simply df, not top, df people dot join. And in fact, I only need to select these three columns. So I'm gonna just, copy and paste what I've written above, and then I'm gonna join that with the df top. And obviously the key variable is player ID. And if I do this, now I can see, it takes a while, but now I can see the merged table. Okay, so now I have the first name and the last name of the players. So it becomes much clearer. So yes, I was right. The third one was Babe Ruth. The second one is Hank Aaron. I see the names of Albert Pujols, Ken Griffey. I think it's Junior by looking at the year tag. But anyways, you can see that you can create a new table like this by combining the information from two different data sources. So obviously, other than summation, you can take the average, you can take, whatever aggregation you would like to have. And all of that is in um, quite nicely explained in the PySpark documentation, which I provided the link in the lab materials. So feel free to check out. And in fact, the documentation is pretty easy to read. So I'm pretty sure you'll have no problem understanding what's available over there. Now, before to jump onto the in-class activities, here is one last thing I want to show you. So in fact, what we're doing here is based on the PySpark Sql library. And what that means is actually everything is based on kind of a SQL interface. So if you are already familiar with SQL, you probably have noticed that the way that the functions are called are quite similar to the actual SQL syntax. So in fact, you can create a SQL interface directly from PySpark. And by the way, this is optional. So if you don't know, only if you know SQL, okay? If you don't know SQL, don't worry. If you know SQL, this is kind of useful thing to know. So let's say this is a Spark data table, data frame, sorry. And you can create or replace temporal view, and then you can name this as people. So that by doing that, I've just created a SQL table. Now, here's one of my favorite things about PySpark, which is you can call SQL query within this quotation mark. So spark.sql, I'm just going to, go with the simplest SQL command. Select everything from the table named people. Okay, so we just converted the data frame into a SQL table. Okay, and spark.sql, and within that function, you can provide a SQL query, and it will return a data frame, okay, by running that SQL query. Okay, so I'm just showing you that the SQL queries are available. So if you happen to know what SQL is, and if you're already familiar with SQL commands, then learning PySpark is going to be way much more, way much easier, because it's basically, building upon the SQL syntax. So I don't know, select everything from people where birth year is greater than 1980. How about that? And then, you can send that SQL query. So this is a SQL query, okay? And the result of that is exactly the same as, DF people where DF birth year is bigger than 1980s. Okay. So that's kind of one last remark about PySpark. So if you already know what SQL is, then I think you can pretty much jumpstart by using this spark.sql. Okay. But if you don't know what SQL is, that's all right. I mean, you've just learned everything that you need to know in order to perform basic data processing.